Japan is right now checking whether a tsunami is heading toward its coastline. Not because of an earthquake, because of a volcano most people have never heard of, on an island most people could not find on a map, that just produced the single largest eruption in its recorded history. And that volcano is not the strangest part of this story, it is barely even the biggest part, because at the exact same moment, on the opposite side of the same ocean, a Hawaiian volcano just broke a record that has stood since the 1980s. The global ocean just logged the hottest single day ever measured by modern instruments. And a chain of cyclones is currently spinning across the Pacific in a pattern scientists only see once every few decades. 3 separate systems. 1 ocean. 1 week. And they are almost certainly talking to each other. I am going to walk you through exactly what is happening, in order, with the actual data behind it. Because right now most of the coverage on this is either buried in volcanology forums or scattered across breaking news alerts that never connect the dots. By the end of this video you will understand why scientists are calling this the most energetic stretch the Pacific has seen in decades, and why the next 3 months matter more than almost any other stretch of weather this decade. Let us start with the volcano that has Japan checking its tsunami models. Its name is Ambe, sometimes called Aoba, and it sits in the middle of the Vanuatu island chain in the South Pacific. Ambe is not a small volcano. It is the largest active shield volcano in the entire country, a broad, sprawling mountain that has been quietly rumbling for most of this year, occasionally sending up modest ash columns that barely made international news. That changed overnight. In the early hours of August 24th, Ambe let go with an eruption that punched an ash column roughly 15 kilometers into the sky. To put that in perspective, that is around 50,000 feet, well above cruising altitude for a commercial jet, and high enough to physically cross out of the troposphere and into the stratosphere. When ash reaches that high, it stops behaving like a local weather event and starts behaving like a global one, because stratospheric ash can circle the planet and linger for months. Type volcano in the comments if you had never even heard of Ambe before this week, because until 48 hours ago, almost nobody outside the South Pacific had either. Here is the part that makes this genuinely historic and not just another eruption headline. Based on the available eruption records for Ambe, this appears to be the largest blast that volcano has produced since instrumented monitoring began. For comparison, the last time Ambe caused serious global attention was the 2017 to 2018 crisis, when the entire island of roughly 11,000 residents had to be evacuated after weeks of ashfall, acid rain and crop destruction. That eruption sent ash to around 10 to 12 kilometers. This new one went higher, arrived faster, and struck with far less warning. Because the eruption happened at night, satellites first caught it as a glowing thermal signature before sunrise revealed the true scale of the ash plume. Japanese monitoring agencies picked up the signal quickly and immediately opened an investigation into whether the blast could generate a tsunami capable of reaching Japanese shores, similar to how the 2022 Tonga eruption sent shockwaves and sea level disturbances across the entire Pacific basin. As of this recording, that assessment is still active. This is not confirmed as tsunami generating, but the fact that it is even being investigated tells you how seriously monitoring agencies are treating the size of this event. Now here is where it gets interesting. Because Ambe is not erupting alone. Roughly 4,000 miles away, on the big island of Hawaii, the Kilauea volcano just fired off its 54th eruptive episode since this current cycle began in December of 2024. If you have followed volcanic activity for any length of time, that number should stop you in your tracks. The previous record for eruptive episodes in a single Kilauea cycle was 46 episodes, and that record took 3 full years to set, between 1983 and 1986. This new cycle just blew past that pace, hitting 54 episodes in a little over a year and a half. Kilauea is not just active right now, it is erupting faster than it has in modern recorded history. During this most recent episode, lava fountains at the summit reached roughly 500 feet into the air, and the eruption plume climbed to around 17,000 feet. Ground crews and monitoring instruments picked up an earthquake at a nearby seamount in the days before this episode began, and scientists watched pressure data at Kilauea's East Rift Zone tick upward right afterward, the same rift zone responsible for destroying more than 700 homes back in 2018. That connection is still being studied, but it raises a real question. Are these two separate hotspot systems, thousands of miles apart on opposite sides of the Pacific, somehow being driven by the same underlying pulse of heat and pressure moving through the planet's crust? Comment Pacific if this is the first time you are hearing that two major shield volcanoes erupted at record pace within days of each other. So we have two of the planet's most active volcanoes, both breaking historic records in the same week. That alone would be a big story. But it is happening inside an ocean that is doing something equally extreme. On August 22nd, the European Union's climate monitoring service, Copernicus, confirmed that the global average sea surface temperature hit 21.1 degrees Celsius, the hottest single day the ocean has recorded since satellite tracking began in 1979. That broke the previous record, set back in March of 2024, and climate scientists are blunt about why. A powerful El Niño is stacking directly on top of decades of long-term ocean warming, and the two effects are compounding rather than simply adding together. This is not a normal El Niño. Forecasters are now projecting it could become the strongest El Niño ever measured, potentially surpassing the historic events of 1877, 1982, and 1997, the benchmark years scientists have used for nearly a century and a half to define what a super El Niño even looks like. Subsurface ocean temperatures in parts of the equatorial Pacific are running roughly 10 degrees Celsius above normal at depth, which is an almost unheard-of anomaly. And critically, this El Niño has not even peaked yet. The typical peak window for an event like this is October through December. We are still weeks away from the point where things are expected to intensify further. If you are new to how El Niño actually works, here is the fast version. Every few years, the trade winds that normally push warm Pacific water toward Asia weaken or reverse, and that warm water sloshes back toward the Americas instead. That shift in ocean temperature reshapes atmospheric pressure patterns across the entire planet, which is why a warm patch of ocean near the equator can trigger droughts in one hemisphere and flooding in another, thousands of miles from where the heat actually is. And El Niño has a very specific fingerprint in how it moves storms around, which brings us to what is happening in the sky right now. Type cyclone if you have noticed how many named storms have been swirling through the Pacific lately, because that pattern is not random. One of El Niño's clearest signatures is a shift in cyclone activity away from the Atlantic and directly into the Pacific basin. Right now, Hawaii is still recovering from Hurricane Lala, a storm that struck with enough force to damage infrastructure and close parts of Hawaii Volcanoes National Park, the same park currently hosting Kilauea's record-breaking eruption cycle. Meanwhile, a cluster of tropical systems is currently active off the coast of Baja California. Another storm just crossed the southern islands of Japan on its way toward mainland China, and additional disturbance zones are spinning up near Guam, all happening simultaneously. Meteorologists track this kind of widespread simultaneous cyclone activity as one of the clearest possible signals of a strengthening El Niño. And by that measure alone, what we are watching right now is about as textbook as it gets, just amplified to a scale that is pushing past historical precedent. So let us zoom out and connect what we actually know. We have the hottest single day the global ocean has ever recorded. We have an El Niño event on pace to become the strongest ever measured, and it has not even peaked yet. We have Kilauea erupting faster than at any point in its documented history. And we have Ambe, a volcano most people never think about, producing what appears to be its largest blast on record, serious enough that Japan is actively checking for tsunami risk. Are these events directly causing each other? Scientists are still working through that, and it would be irresponsible to claim certainty where there is not yet certainty. But there is a real physical mechanism worth understanding here. Undersea volcanic activity, including activity we cannot see or measure because it is happening on ocean floors we have barely mapped, releases genuine heat and carbon dioxide directly into deep water. It is a small contribution compared to the scale of a full ocean basin. But in a system already primed by El Niño and long-term warming, every additional input matters. And it means that some of the weather forecasts you are seeing right now may be underestimating what is actually driving conditions, simply because standard forecasting models are not built to account for volcanic heat flux from the seafloor. There is one more layer to this that most coverage is completely missing, and it is the layer that actually belongs on a channel like this one. While all four of these systems have been unfolding, the sun has not been quiet either. Over the past several days, multiple M-class solar flares have fired off, including one substantial flare that pushed well past the M6 threshold. Flares at that level inject additional charged particles into the ionosphere, and there is at least one solar storm currently inbound toward Earth, with a second one following close behind it, expected to arrive within the next few days. Space weather agencies have already issued a minor geomagnetic storm watch, with the potential to escalate to a moderate-level storm as those particles arrive. Now, to be clear, nobody is claiming solar activity directly triggers volcanic eruptions or steers hurricanes. That is not how this works, and you should be skeptical of anyone who claims otherwise without solid evidence. But increased ionospheric charging does measurably strengthen electric current systems that extend down through the atmosphere and, some researchers argue, subtly influence tropospheric weather patterns and storm behavior at the margins. Cyclones themselves carry their own electrical signature too, generating detectable plasma currents that can shift the local magnetic field by a fraction of a nanotesla. A small but genuinely measurable effect. Layer that on top of a record-breaking El Niño, a record-hot ocean, and two major volcanic systems releasing gas and ash with real electrical charge of their own, and what you get is a planet where an unusual number of energetic systems are all interacting inside the same narrow window of time. That convergence, more than any single event on its own, is what has people who track this data every single day paying such close attention right now. Comment energy if that solar piece is something you want broken down in more depth in a future video, because there is a lot more to unpack there than we have time for today. There is also a strange twist worth sitting with before we close this out. Massive volcanic eruptions do not only add heat to the planet. Sulfur dioxide released by large eruptions can form reflective particles high in the atmosphere that actually cool the Earth's surface for months or even years afterward. It sounds counterintuitive. A volcano potentially cooling the same planet its sister volcano is helping to heat, but that is genuinely part of the physical record. A single eruption large enough, and there is a real chance we could see multiple large eruptions cluster together the way they have at points throughout history, could measurably offset global temperatures, at least temporarily. It happened during the Bronze Age collapse thousands of years ago, one of history's great unsolved mysteries, when a run of clustered earthquakes, volcanic eruptions, and prolonged drought struck within a relatively short span of decades and helped unravel some of the most advanced civilizations of the ancient world almost simultaneously. Entire palace complexes were abandoned. Trade networks that had linked the Mediterranean for centuries collapsed, and displaced populations, later remembered in historical texts as the Sea Peoples, were pushed to migrate across the region in search of land that could still support them. Nobody is suggesting we are anywhere close to that scale of disruption today, but it is a genuine reminder that Earth's volcanic, oceanic, and atmospheric systems do not operate in isolation from each other, and history shows us what happens when several of them get energetic at the same time. We are obviously not there, but the pattern of multiple energetic systems compounding at once is exactly the kind of thing that shows up right before major climate shifts throughout Earth's history. And that is precisely why scientists who study this for a living are not shrugging this week off as ordinary. So here is where things stand heading into fall. Kilauea shows no sign of slowing, with its next episode expected in roughly 2 weeks based on the current recharge pattern. Ambay remains under close watch as agencies finish evaluating the tsunami risk from its record eruption. The Pacific cyclone season is still building toward its usual autumn peak, and this record-breaking El Niño is forecast to keep intensifying into October and November, months that historically produce the most extreme outcomes once a super El Niño fully matures. Comment tracking if you want me to keep following this as it develops, because every one of these 4 systems is still active and still evolving right now, and the next month is genuinely going to tell us how far this goes. If this is the kind of coverage you want more of, hit subscribe, because I track Earth's volcanic, seismic, and space weather activity closely, and this particular stretch is shaping up to be one of the most energetic periods the planet has produced in decades. Let me know down in the comments which of these 4 events surprised you the most: the record eruption in Vanuatu, the record-breaking pace at Kilauea, the hottest ocean day ever recorded, or the historic El Niño building underneath all of it. I will see you in the next one.